and landing platforms for rockets, so a rocket can land there and it's better surface. And also space labs, they do biology experiments on the ISS. So it's on the ISS, you know the ISS, right? The space station. There's an experiment on the ISS right now that is there, and it will come down when? In a week?
It's already back in tissue.
Oh, it's already back.
They're waiting to...
It already returned recently. It's been up there for 2 weeks. And now they can see what the experiment was a success and see the data analysis. So, I don't know if you can imagine a space elevator, so I put a picture there. So, then on the left side is the Earth. Okay, you see the equator, this is the red line. And there's a long rope, a really long rope, that goes from the equator, and it will always stay on the same point of Earth, so it rotates with the Earth. And then the climber, that's the gray box there, that's the vehicle that will drive along the rope until it releases a satellite, then that satellite is in the orbit, and then we'll go back down and catch the next satellite and bring up satellites or even astronauts to space. And you could start with your spaceship from just a higher altitude. You don't start from the Earth, from the ground, because you need fuel to get from the Earth with your rocket around the Earth in an orbit. And you would not need that amount of fuel because you drive up there electrically with a vehicle and then start from there. So here on the left, you can see a satellite that is always on the same point from the Earth's surface. Okay? So that's how it works. There you would need to put the counterweight, and then the rope, you see that dotted line there. If that would be a rope, you could just drive up there with an elevator. Okay? So, what LiPA models do we build? We actually brought some here. Simon, maybe stand up and show the model. That's actually this one here. So that's about 3 kilograms. That's not too heavy, but it doesn't carry payload. It's just for testing. And it should go about 20 meters per second in speed. And yeah, it has a 2-wheel drive. I think the next picture is a little more in detail. Well, I would start over there. Can you just give it around quickly? I will put it here on the desk so you can have a look. And then I will give it around here, okay? So you see here the 2 wheels. That's the motor here. So if you turn that, the wheels also turn. Yeah, you will get it too. I will just go around so we have like a group of 5 that can look at it at the same time. Okay?
Yeah, I think.
Here you have the electronics that control the motor, and also the sensors here that detect if there's the ground coming up, so it has to brake. And that's how it works. But you will see it more in detail because we will take it apart and show you the parts as well. So let me just for you too. Okay. So if you spin the motor, you see that the wheels inside turn. And this will drive on a rope. Okay? The electronics do the control, so when you press here, it will start. So you have the control, the electronics. Here they control the motor. The motor turns, you see the wheels turning inside. And the battery will go in here. And you have the sensors that detect the ground or the end of the rope, so it will stop automatically. And last one here. Can you all see? So that's the model. You have the controls here with the electronics. Well, we will go into detail and actually program these electronics. You can program them yourself. Yes. Sorry. Sorry, I didn't hear you. Speak up.
What is the space elevator?
What will it do?
What? What it does? This is driving up the rope. Let me just go back to here. Okay, so this part, you see this gray rectangle. Okay? So this is this part here, so it moves. It drives along the rope from Earth into space, then it stops there, it releases a satellite, and then it drives back down. It's like a cargo vehicle. It carries things into space, but with an electric motor, not like a rocket with fuel that is burned, but with the electric motor here. So a battery, maybe solar panels, and it goes with an electric motor. So for us, it would go up like this on a rope. Okay.
So that's what helps the rock. It takes a satellite to space. Is it a vehicle that takes a satellite to space, leave it there, and then this comes down?
Yeah, it's just a carrier. It comes back down, grabs the next satellite, drives it up. Or even if you want to go to the moon or the Mars, you could carry maybe the rocket up there, and you go the first part with electric energy, and from there you fly with an actual rocket, but you save a big amount of fuel if you don't have to start from Earth and go into Earth orbit and from there to Mars. That's the idea. Also, you could land on Mars with that. So you bring this thing to Mars, throw down your rope, and you just send the elevator down to the surface. With your ship, you are waiting in orbit, and then when this comes back, you fly back. So on Mars, you would need to land with burning fuel. You can't land with parachutes alone, and you would save.
Are you sure?
Any question?
Okay, let me ask you guys, when you hear a payload, what does it mean? Because Uncle will be seeing a lot of payloads, so when you hear a payload, what does it mean?
Any idea?
Yeah, maybe you're correct. Say it.
Yeah, that's exactly right, the cargo. So that is the cargo you want to carry. So it's the same with the rocket. A rocket itself is just the vehicle that brings something up into space, and the satellite or whatever it brings into space, that is called payload.
Okay.
This is the load that you bring up to space.
For example, if a woman buys a sack of rice at the market, a big sack of rice, and she puts it into the trotro, that's the payload, the sack of rice.
Because you paid for it, right? It's the same for the rocket. You pay that your satellite goes into space. That's what you pay for. You don't pay for the vehicle. That's why it's called payload. Okay?
There was a hand up there.
Oh, thank you. So that is a different model. You can see it on the picture. It's different as this model. This is bigger, it's about that size. And here you see how it goes vertically up on a rope. So that is what you would, the model that we will start building in Munich. So this will carry a load, a payload. And this is 100 kilograms, so about. So I hope you now have an idea. Can you imagine, do you understand what the space elevator is for now?
Yes.
Okay. So today I would start with building the battery, because we brought it in pieces. We didn't really build the battery, because we wanted to show you how we do build a battery. Has anyone seen how to build a battery of you? Okay. Use these battery cells here. You can just give it around. That is one battery cell. That is like the same in your mobile phone or in my laptop, but it's just differently shaped. And we will connect 6 of these to make a big battery that can then drive the climber and give enough power to the motor so it really goes.
And batteries are in everything. So batteries are in these small tablets, batteries are in your cars, batteries are in the phones, batteries are in these mouses. Everything has batteries. you look inside. For example, there the battery is taken out, but maybe here it's still inside. And these ones, they're the same, but just bigger. And we need them to be really important or to be load carrying and strong. So that's why they are big. They are strong and big. Yeah, can I have that one? So this one is a small one. You can see it's the same shape as the battery, but this one is bigger and more powerful. These are normal batteries, and these ones are the powerful ones. And now we want to build them together. And these ones give us the power for driving it. So this one stores energy.